Welcome to the math record. Today I'll be covering arc length. So first, let's find out how to get the arc length formula. This won't be a complete proof, but just a basic idea on why the formula is true. So first, let's draw a curve to understand this. So to find the arc length, what we could do is choose like infinite amount of points, but I'm just going to show some points to see how it could be done. Okay. Now what we do is that we could find the distance between each 2 points, each successive point. So it looks something like this. Now, if we add up all those distances together, we could get the arc length. But it's just a little bit off because when we're taking distances, those are straight lines, while the arc is a curve, which means it bends. So to fix that, we just need to choose infinite amount of points so it gets closer and closer. So rather than choosing this amount, we can have even more. But to do that, that would mean we're going to be using integrals if we're choosing an infinite amount of stuff. So the arc length, so I just put AL for arc length, is the integral of the distances. Now, how do we calculate a distance? Well, let's just choose 2 points, and I'm gonna separate them out a lot, but usually they're supposed to be really, really close, but I'm gonna separate them out a lot so then you can see what's happening. Okay, so this distance, we could break it down into its x and y, but since these are infinitely really close, that means the distance is dx and the y is dy. So it's just the change in x and the change in y, but really, really close. That's what dx and dy mean for our derivatives and integrals. Now what we could do is that we could take the square of both of them, add them together, take the square root to get our distance. Now the trick to simplify this, because we're working on x and y and we only want to work with x, then basically we could multiply by the square root of dx squared, divide by the square root of dx squared. So this simplifies to 1, but since we have a radical and a radical, we could combine them together. So dx squared plus dy squared divided by dx squared. So that combines here, and then this we could simplify. So dx squared square root, that's just dx. So this part matches with this. And now to take this, we just have to have dx squared divided by dx squared, that's 1. And dy squared divided by dx squared, that's dy over dx squared. Well, that looks pretty familiar, and that's just a derivative. So we could substitute all this back into our arc length formula. So our arc length formula is equal to just the integral of the square root of 1 plus dy over dx squared, so the derivative of your function squared in respect to x. Okay, let's delete this and let's try an example. Move this to the top. So let's say we have an arc f of x is equal to x to the power 3 over 2, and we want to find the length of that arc from x equals 0 to x is equal to 4. Okay, well, let's set up our arc length formula. So integral of square root of 1 plus our derivative. Let's take the derivative of that. So our derivative is equal to 3 over 2 x to the power of 1/2. So when we square that, the square of 3 over 2 is 9 over 4. The square of x to the power 1/2 is x. And then we do it in respect to x. And we're going from 0 to 4. I'm going to delete a bit of it because it's a little bit too long. From 0 to 4. Okay, now a radical is the same thing as writing 1/2 to the power 1/2. So when we integrate this, we use the power rule. So that's just 3 over 2, because 1 plus 1/2 plus 1 is 3 over 2, and then 1 plus 9/4 x is inside. Now we take the derivative of this. This is 3 over 2, 1 plus 9 over 4x. And then since it's a function inside of a function, we need to work with a chain rule. So the derivative of 1 is 0. The derivative of 9 over 4x is 9 over 4. So that means we need to multiply by 9 over 4. So this comes out 9 times 3 is 27, and 4 times 2 is 8. Okay, so that means the derivative of this is 27 over 8 times this. So we need to scale this down by 8 over 27. Okay, that would be our integral. Let's delete that. We don't need it anymore. And we just need to evaluate it from 0 to 4. Now we plug in 4 in here. 9 times 4 is 9 over 4 times 4 is 9, plus this one is 10. So that's 8 over 27. And then 10 to the power of 3 over 2. And then minus, plug in 0. 9 over 4 times 0 is 0. And then 1 to the power of 3 over 2 is just 1 times 8 over 27. So that means your arc length is this, which you could just find an approximate answer using your calculator, because 10 to the power of 3 over 2 doesn't really simplify to a really nice number. Well, thanks for watching, and with this, basically chapter 4 is done. In the next video, I'll introduce sequences and series.